Hi, I'm Francis Chung.
I'm Mani Subramanian, and we both work for the Patterns and Practices team at Microsoft.
And today we'll be talking about dependency injection with a focus on testability. So today we'll be really giving you an overview, an introduction to dependency injection, why you need it, and also talk about testability. We'll first talk about some design goals that will lead you into why you need it. We'll show some examples of some tightly coupled code and some loosely coupled code and see, we'll compare and contrast. We'll introduce you into dependency injection, also several IOC containers and specifically Unity, and show you how you can use that. We'll show you testability, we'll show you how to unit test some of the code that we will show you, and we'll end with some Q&A.
Yeah, I just wanted to add one thing. So we decided to show the demos in Unity because that's a project we have been actively working on, and we are kind of familiar with Unity. You might very well use some other dependency injection container too. There are plenty of very good other options out there.
Very good. All right, so first, there are many design goals you may be curious, that you may be concentrated on, but we'll concentrate on maintainability, testability, and parallel development in our talk today. So maintainability is all about being able to update your code based upon changing requirements, based upon changing bugs, or so forth. So being able to change your code without too much effort, right? Testability is really about the ability to test specific parts of your code in isolation. So it's important to be able to do integration tests and user acceptance tests, but we'll talk more about unit testability in our talk. And also parallel development. That's a really interesting one. It's not your typical utility. Sometimes you may have things that are dependent, in which case some people may be waiting for other people to finish their code before you can start yours. And that you don't want to spend a lot of time waiting. So let's dive right in. All right, loose and tight coupling. Let's take a look at this code. This is the type of code that I might have written a lot of in my past life, but now that I've learned the error of my ways, I don't write this code so much anymore. Let's take a look at what this does. So we've got an order service. In the order service constructor, we have construction of a DB order service and also construction of a DB logger. I put some ellipses in there because there's a lot of work that may come into play when you need to create an instance of a DB order store. For example, you may need to go and grab a connection string. You may need to get some other dependent services. There may be a lot of things that go into constructing a DB order store. Same goes for the logger, right? You may need a connection string for the DB logger. This is the type of stuff that you may or may not want your order service developer to be writing. Every client of the DB order store, DB logger, would have to be able to write a lot of the same code. So you have some code repetition here. Also, you have this implied lifetime management here. In this case, the order service is creating an instance of these two dependent services and is holding a reference to them for the lifetime of the order service. Well, the DB order store and DB logger may have some startup costs. They may not want to pay every time you create an instance of order service. You may want to create an instance of the order store and hold on to it like a singleton and pass it to every instance or client that needs it, right? So there's that coupling there. Also, you have this coupling of the development effort. In this case, the order service needs to have the DB order store and DB logger types available in order to even compile. I can't compile this code unless somebody gives me those types. So there's that coupling. Also testability. So testability is taking a hit here because if I were to unit test the order service class, specifically the process order method, I really would be testing the logger and the DB order store, which may or may not be configured correctly. So if I run those tests, who knows? There may be a lot of setup costs I may have to do in order to clean up the data, get it in the right shape. So unit testability may be a little bit of maybe harder in this case, right? So the pros, it's pretty straightforward to write. Creating the new instances is pretty straightforward. Most people will do this kind of stuff. But the cons is that it's hard to maintain, right? If I want to update or add some features to DB order store or DB logger, and that feature may show up in the constructor, well, I'd have to crack open the code for the order store, the order service, in order to really take advantage of those new APIs. So it's kind of hard to maintain. Also, the unit testing. We talked about how hard it is to unit test. It would be really difficult to unit test. It may be easier to integration test, but unit testing would be very difficult. Again, hard to develop in parallel because I have a dependency on those concrete DB order store and DB logger. So, all right. Anything you want to add to that?
Yeah, I'm good.
Okay. All right. Now let's take a look at the service locator. Now, the service locator in this case is taken right out of the Common Service Locator project, which is really kind of a wrapper or an interface that a lot of
popular dependency injection containers they support.
Exactly. Yeah, there are adapters to provide service location, the service location functionality as wrappers over these very common DI containers. But let's take a look at the usage. In this case, the process order method is actually calling the service locator to get an access to an instance of the order store. So right now, we've achieved a little bit. We've achieved some decoupling in that I'm not coupled to the DB order store concrete implementation. I'm asking for, give me something that implements iOrder store. That's kind of nice. And another nice thing is that because I'm using the service locator in the process order method call, I'm actually getting an instance at the latest possible time. So, for example, if the process order was called very infrequently, and you didn't really need to get an instance or new up an instance of the order store very, very often, this would do it at the last possible time. Okay, so that's an advantage. The downside is that you have this concept of a service locator, and now you have to tell the service locator how to create an instance of iOrder store, right? So that's a downside. So again, it's pretty straightforward to get a service. You just ask the service locator for the service, and you can achieve some lazy instantiation. That's kind of nice. Downside is that now you're coupled to this concept of a service locator. And you're also coupled to the idea that the service locator needs to create the object, so you have to tell it. You have to do some training. You either have to train the service locator directly or train the underlying DI container. Okay. Next thing is testing. If you want to test it, well, the test will call the service locator, and you have to make sure the service locator is populated with test objects when appropriate. Oh, by the way, if there are any questions, we'll be answering them at the end, but feel free to send in your questions. We'll get to them as soon as we can. All right? And last thing is that it's now that you have used the service locator and you can use it throughout your code, it's harder to find out what the true dependencies are of your class. So in this case, the order service will depend on a logger, and it will depend on an order store. Now it's mixed throughout your code where these dependencies are. You actually have to walk through your code to find out that it will eventually need one of these things. So when you run your unit test, you'll discover, oh, wow, I need one of those things. I need to go and configure it. It's not as obvious. So that's why I think a lot of people consider the service location an anti-pattern nowadays. All right, let's take another step and introduce the idea of poor man's DI. In this case, we've achieved some testability here. What we have here is an alternate constructor. So we've got a default constructor that goes and creates an instance of DB store and DB logger, as we've seen before. But we have an alternate constructor that allows you to pass in these dependencies through the constructor parameters. So in this case, the iOrder store and iLogger are passed in and can be used at test time versus at runtime. The default constructor will be utilized. So that's kind of nice, but you can see that we're still coupled to DB order store. We're still implying the lifetime of those things. So the lifetime of DB order store and DB logger are still coupled, or in this case are going to be one-to-one order service. So may or may not want that. So the features, if you want to update the usage of DB order store, the maintenance takes a hit, right? So again, testability is great. Hard dependencies, not so great. Still responsible for the construction, so the complexity around that is still there. And again, maintainability takes a hit. All right, finally, full-on DI. So it's very similar to the poor man's DI, except you don't have the hard coupling to the concrete classes. So here you've got just the interfaces. You're programming just to the interfaces. You're receiving those interfaces through a constructor. There's no default constructor. You have to pass in the order service, into the constructor of the order service. You have to pass in an instance of iOrderStore and an iLogger. You have to pass those in. So we're saying that you can't have an order service. You can't have one of these things unless you pass it its dependencies. So it's really clear what the dependencies are. Okay. All right. So the advantages again, decoupled. So we're decoupled from the concrete instances or the concrete types, but you are coupled to the interfaces. You can easily determine the dependencies based upon that constructor. You can easily test in isolation because you can then pass in mocks or stubs into the constructor at test time. And then you could pass the real running ones at runtime. And also allows you to have parallel development because you could program against these interfaces and somebody else that's working on the logger, on a real implementation of iLogger and real implementation of iOrderStore can be working at the same time. But there's some magic here, right? Who actually manages the real objects? So that's how we get into dependency injection. So DI, as we've mentioned before, helps with decoupled code, helps with this testability, and helps with parallel development. But one really interesting thing compared to other models, for example, factories and service location, is that those other ways of getting the dependencies are really pulling those dependencies. I'm either constructing them myself or asking them of a factory, give me my dependencies. I know how to manage my dependencies. DI is the reverse. It's really getting them pushed into the service that needs them. So that's why it's flipped around.
Yeah, I know we talked about the abstract factory and the factory method. So basically, if you are using an abstract factory, you will have a virtual method like a create store method, which will create a concrete instance of the order store for you and give it back to you. So even there, the dependencies are buried inside the class itself. You can sort of test it by you creating a mock order service and overriding the virtual method and getting an instance of a mock order store from it, but it's a bit harder to do it with the abstract factory pattern, with the factory method pattern. With the abstract factory, you will have a class like an order store factory class, and that returns the instance for you. But even there, the dependencies are buried inside. I mean, if you want to know the dependencies of the order service, still you need to peek under the hood and look at the code of the order service in order to find out the dependencies. So
sprinkled throughout the whole order service, right?
And that's why, I mean, when you're using dependency injection, these dependencies automatically appear, and the responsibility of creating those instances are delegated to some other component. We'll talk about it soon. And that's why we use the term inversion of control. Basically, the responsibilities are inverted. In this scenario, the order service is no longer responsible for creating the instances.
Right. It doesn't pull them. It actually gets them pushed into it. So it doesn't know. It doesn't know a lot. It doesn't know the lifetime of the dependencies. It doesn't manage any of that.
Yes.
Okay. So let's talk about types of dependency injection. We've already shown an example of constructor injection. That's by far the most common form of dependency injection, where you're defining your dependencies through the constructor parameters. Another way is property or method call injection. There is a time and place for these too. In this case, this really is used when you don't control the construction of your service or of the entity that you're dealing with. Let's say you're dealing with WCF or SharePoint, where you receive an instance through the framework. The framework will give you one of these things, but you may want to provide it some other services, some other dependencies for it to do its job. You didn't participate in construction, so you really can't have a a parameterized constructor, but after you get an instance, you could set a property, or you could call a method like an initialized method, right?
Right.
So those are examples of property and method call injection. Anything to add to that?
No, we're good.
Okay. All right. So let's show a demo using Unity.
Okay.
Oh, you may need to stop the presentation. Escape button. Okay. That's a cute kid.
That's my daughter. So how come the sharing doesn't work?
Go and duplicate. Windows P. All right.
There you go. So what I have here is I have a code of an online store class, an online store application. I have a console logger implementation of an interface iLogger. So let's see how you use Unity container with this. So this is a very basic naive example. What I am doing here is I am creating an instance of the container. I am registering a type in the container. I am saying that the console logger implements the iLogger interface. I am telling the Unity container that by calling this method register type, I am then resolving the instance from the Unity container. That's pretty much it. When you get what Unity does under the covers is here is when I am registering the type, it uses reflection to find out information about the type and learn about it. And after that, what Unity does is it builds an expression tree, and it compiles and caches the expression tree, and that expression tree is used to build the concrete instance and return it back to you. I can also give a name to this registration. I can, for example, call this console, and let's say I have a family of different loggers which implement the iLogger interface. I have an event logger and I have a debug logger. I can give different names to these different instances, and I can register it in the container, and I can request for a logger with a particular implementation of the logger. Now the other thing Unity or DI containers allow you to do is you can specify a lifetime manager here. So you can say I want to use a container control lifetime manager, and when you specify different lifetime managers, basically you are telling the container how to manage the lifetime of the instance that was created. So if you use the container control lifetime manager, for example, what Unity does is it creates the instance the first time, and it holds a reference to it. So when you call resolve in subsequent calls, first time it creates instance for you, and then it basically keeps a reference to it and returns the same instance every time, and essentially you are getting something like a container scoped singleton here. So you are getting the singleton pattern for free. This is a very naive example. You would not probably use this in a real application. You are registering just one type mapping in there. So let's look at a more complicated example, which is more realistic. So I have the remaining parts of the order store application here. So I have a bunch of domain entities here for the order. I have an order service which takes an order store, iOrder store as dependency. It takes iLogger as dependency, and it basically has a process order method. The process order method saves the order and updates it and returns the updated order. Now for the order store, I have an iOrder store interface which saves the order to some place, maybe a database, but in this case I have a queue implementation of the order store. and it has a constructor which takes a storage account and a save method which saves the order using this configuration information to a queue. The code is not shown here, this is just like skeleton code. Now let us see how you can use Unity to wire up all these different instances and construct the objects when you have an object graph like this. So I have this here. What I am doing is I am creating against an instance of the container. You will probably use one instance of the container through the lifetime of your application. I am creating an instance of the cloud storage account here. Basically, I am reading the storage account connection string from configuration, and I am creating an instance of the storage account object. Well, one thing, one facility the container provides is you can register an existing instance of the object. So you do not have to just do type registrations. You can register an existing instance, and you can use that to perform dependency injection. The other thing I am doing here is I am registering a type mapping. I am saying that the Azure Key Auto Store implements iAutoStore interface. I am saying that the Unity has to use this constructor of the Azure Key Auto Store, and the constructor takes a cloud storage account type, it takes a logger type, and it takes the Azure Queue name, which I would have probably read from configuration. Then what I am doing is I am registering the logger, and I am specifying a container control lifetime manager. Let us assume that the logger does not store any state in it, and it is thread safe. Either it is thread safe or it does not store any state in it. So I am registering the console logger here using container control lifetime manager. Then I am registering the order service here, and I am saying that order service implements iOrder service interface. Now when I call resolve, what Unity does under the covers is it figures out all the inner dependencies in the object graph. It creates instance of them if it needs to create a new instance of it. If it already has it and it is tracking it, it uses an existing instance, and it wires up all these different objects dependencies in the object graph and gives you a new instance of the order service, calling the constructor of the order service. Now how Unity basically creates instance of the order service is it finds out the by default it uses an algorithm which finds out the largest matching constructor, and it finds out the parameters for that constructor, and it basically recursively builds all the dependencies in the object graph.
So when you say largest constructor, you mean
the constructor which has which has the most number of parameters.
Right.
Yeah. So now that we looked at the demo, let's go back and
actually before you leave that,
yeah.
Here you did a register instance. That storage account, is that going to be treated as a singleton?
By default, it's treated as a singleton. It basically tracks the instance for you, and if let's say the storage account instance was holding disposable resources, those disposable resources will be cleaned up when you are disposing the container itself. So now that we saw a demo of how Unity is used and some of its inner workings, let's try to define what an IOC container is. So an IOC container is nothing but a repository of types. It has a bunch of key value pairs which map the interface or abstract class or the abstraction to the concrete type. It also you can for example, you can register a type in it. Let's say you don't have the abstraction, the interface implementation separation, and you are using a third party library and it has only the concrete types in there. You can register concrete types in it too. You'll typically do registration in the application startup. Like for example, you will do it when the application starts in ASP.NET MVC. In an ASP.NET MVC app, ASP.NET MVC has some hooks where you can supply some startup code when the application starts up. So you'll do registration during application startup. You can request for a new instance of an object from or an existing instance, from the container. The container does recursive resolution, which we saw. It wires up all the inner dependencies and builds object graph for you. Lifetime management is also typically supported by containers, but there are a lot of differences between containers in the way they manage lifetime. So we will go into that a little more in detail in some of the future slides. Now I'll show you a list of different containers here. So all of them are very good. You could easily use one over the other. We will look at the criteria of selecting a particular container also in another slide, but to figure out which containers are popular and which ones are good, what this resource here has has a scoring system where it scores the container based on the number of downloads, this is the popularity and the level of documentation and things like that. So that's one place that you can look at to find out which ones are the more popular ones right now in NuGet. Now let's look at some of the additional features which containers, which IOC containers provide. So you may find some variation in the level of support in these features across different containers. So one great feature is auto registration. Now let's say you have a very complex app. It has a lot of different interfaces and their implementations. It can be quite painful to write a bunch of register type statements in your application startup. So one facility a lot of containers provide is they provide an assembly scanning feature where you can specify a list of assemblies, and based on some naming convention, for example, the container looks at interfaces and their implementations which follow a similar kind of naming convention, and it bulk loads all these registrations of these similar types using, you can use just one statement for doing that. It's a pretty nifty feature to have for bigger projects. The other feature which many containers provide is XML configuration. So instead of specifying all your registration information through code, the container basically it allows you to specify your entire object graph using an XML file, and it basically wires up reads the configuration file and wires up all the dependencies for you. In addition, some other containers they have ASP.NET MVC integration. So basically with ASP.NET MVC integration, the ASP.NET MVC infrastructure, the framework has great built-in support for dependency injection. So when you hit a URL of an ASP.NET website, the infrastructure finds out the controller and the action which is going to be which you are targeting when you hit the URL, and it passes on this information to a dependency resolver, and the dependency resolver is responsible for creating the instances of your controller, and basically it constructs all the controller instances for you. Now ASP.NET MVC provides a hook where you can replace the standard built-in dependency resolver with a custom resolver, a dependency resolver, which can be used to do more to do dependency injection. Like for example, if your controller makes use of a repository interface, you can set up the dependency resolver so that it uses the container to create an instance of the repository and inject the instance into the controller, and you can use that. So it has this great built-in facility to it which helps you write more decoupled code.
Very useful. We'll be showing a demo of that later.
Sure, that's great. So another feature some containers provide is interception. So this is a slightly more advanced topic. I'll treat this in a separate slide. So typically in any application you will have to address some cross-cutting concerns, like you may want to do logging or exception handling, or you may want to increment some performance counters. and we tend to sprinkle a lot of these cross-cutting concerns code in, let's say, the business logic of the application. So one facility which allows you to kind of decouple this code from the actual core code of the application is interception. So I'll explain briefly how interception works with Unity. So when you are using interception with the Unity container, let's say you have a customer repository type, and the customer repository has a get all method, and the get all method returns a list of customers, and it's a performance intensive operation, and you want to perform some caching. So when you are requesting the customer repository object from the Unity container, when you are using interception, what Unity does is it creates a proxy of the object for you instead of giving you the real object. And now when the client class it calls a get all method, the call to the get all method goes to the proxy, and the proxy can do some additional pre and post processing steps before the call goes to the real customer repository get all method. So you can hook in what in Unity speak it's called a behavior pipeline. So you can hook in a behavior pipeline there which can do additional things like logging and caching before the real get all method gets called, and you can even return if let's say you can find the customer list in the cache, you can just return without calling the real get all method. So now to use interception with Unity, there are some extra steps you need to do when you are registering the type. You need to basically opt in for interception, and you need to specify during registration the behaviors you want to use for doing the interception. And after that, Unity does the interception magic for you. So now that we looked at some of the features which many IOC containers provide, let's look at the criteria for selecting an IOC container, since there are a whole number of very good options which are there out there. So one I would say the most deciding factor is the supported platforms. Like for example, if you are developing a ASP.NET MVC app, then we want to look at whether the container has a custom dependency resolver which will work with ASP.NET MVC. Another scenario is, let's say you are developing a phone app and you want to target, let's say Android or iOS, and you are using the Xamarin framework. So you want to see whether the container is available as a PCL which supports the Xamarin targets. Unity does support the Xamarin targets. There are other containers also which probably do. The other criteria you may want to look at is you may want to look at how easy it is to set up the container, like whether it supports bulk registration for complex apps. As I said, it's very useful to have that feature. You may also want to see whether the container has a fluent API. If you choose the API option, to wire up all your dependencies through code.
To register your types.
To register all your types through code, then having a fluent API helps to use the container better. Performance is definitely a very good, very important factor, because especially if you are developing really large scale apps and which are deployed on clusters or in the cloud, if you can shave off a couple of CPU cycles, you will save some money. You will utilize less instances. You may want to look at additional features, which is things like interception, which we talked about, and another thing you may want to look at is the extensibility factor. So you may want to, for example, with Unity, you can replace the built-in logic which is used for registering and resolving types, and you can create your own extension which does something different. So if your application down the line, when you are developing your application, if you find that the facilities which the existing container does not offers are not good enough for you, you should be able to replace those easily. Error handling is again I would say a very important thing, because when you are registering types, it's very, if you have a deeply nested object graph, you may miss out a dependency, or if the container is not able to find a constructor, a matching constructor, you sometimes get a very cryptic error message and you don't know what's going on. So I would say error handling is very important. It was very bad in initial versions of Unity. We have tried to make some improvements and made some investments there to make it better in some of the later versions.
Yeah. I think it's much better now.
Okay, that's good to hear.
Yeah. Yeah.
So another thing is licensing. So many of the options we looked at before, they are available using the Apache license. Some containers are not. So depending on your company policy, you may want to look at what kind of licensing is acceptable, for using third-party software.
Yeah.
Yeah. Now the last point is more of a consideration for resource for using the container than a criteria for selecting the container. So you may want to look at the documentation of the container to know how it manages disposable resources. Some containers like MEF, the default is it uses container control lifetime manager. So everything is a singleton. You can specify other options too. Some like AutoFac use a child container kind of approach where it tracks the instance, but you can create from the parent container you can create an instance of the child container which has which will inherit the registrations, and basically you can dispose the child container and it takes care of cleaning up the resources. So this is a consideration. You really want to look at the documentation of the container which you have chosen to figure out how it does the how it tracks disposable resources.
Yeah.
Unity takes a hybrid approach where by default the lifetime manager is transient, in the sense that you get a new instance every time and you are responsible for disposing those instances. But if you use the container control lifetime manager and a recent lifetime manager which we added, which is the per resolve lifetime manager, basically the per resolve lifetime manager is used when you want to create an instance which is shared across a single HTTP request and you want to dispose it once the request is processed, let's say an ASP.NET MVC application. So you had a question?
Yeah, I want to talk about the error handling. I think that's a really important feature. A lot of times when I write code and I've got a service and I say, you know what, I need this, I need a dependency, so I'll just go and add that to the constructor and I'll wire it up and I'll forget, oh shoot, I forgot to register something that actually provides that dependency. That's very common. And without good error handling, that could really stump you. Your code won't run, like, why won't this run? And with good error handling, you'll know which dependencies or which constructors failed. So that's really helpful.
Right. And now we will talk about testability. So Francis will take over.
Yeah. Actually, before we jump into testability, let's give an example of what you talked about before, which is the wiring of the MVC.
Right.
Let's see. Sorry to cover up your beautiful daughter, but so let's give an example of the web, the ASP.NET MVC integration you talked about. So in this case here, I've got a, let's see down here, the online store web. So this is an ASP.NET MVC application, and if I go here and take a look at the NuGet packages, you will see that I actually have the Unity bootstrapper for ASP.NET MVC. This is really helpful because, as you mentioned before, that dependency resolver, it's all wired up here. All I have to do is include that NuGet dependency, and if I go into app start here, it adds these Unity config and MVC, Unity MVC activator, sorry. The important piece is right here, this line right here, that really sets the dependency resolver for MVC equal to the Unity dependency resolver. So this is really where it hooks MVC up with Unity. And over here in the Unity config is where you do your type registration. So the same types we saw in that console app where we registered some things using register instance or register type, register with a container controlled lifetime manager, and just simply without a container controlled lifetime manager. All those are done right here. Okay, so that's an example of how to do that within the MVC integration. So let's talk about unit testing a little bit. Now, what we have here is we've got an order store, an order service that we want to test. And we want to test the process order method of that. So I've got a test project. So I've got my user services implementation. So this is the class I want to test. I want to test this method in particular. And in my test project, I've got a test class here. I'll go ahead and uncomment this code, right? And so what I'm trying to do here is create an instance of an order. I want to create an instance of the order service, the target. So I like to call the thing that I'm testing target. So I'm really clear. I'm not testing anything else. I'm just testing this. So I'm testing the process order method of the target. And I'm just validating that the order that I passed it is the same that is being saved by the order store. Okay, so that's what I'm trying to validate. So what I've got here is a couple of my dependencies all faked out. What I've got here is the order service passed in. I'm passing in an instance of the order store and logger, but I'm creating them using basically stubs. Okay, or many people call them fakes, or actually mocks is a more popular term. So where am I getting these? Let's take a look at my test project. The iLogger interface is actually defined here. And I want to create an instance of that. You can use other frameworks, other testing frameworks like MockQ or RhinoMox. They do virtually the same thing as the Microsoft fakes. In this case, we're using the stubs part of the Microsoft fakes framework. What I want to do is I want to create an instance of the iLogger interface and create a concrete instance of the iLogger and a concrete instance of the iOrder store. And so in order to do that, I'm just going to right-click on that reference. Now this works in Visual Studio 2013. I'm not sure what flavors of 2013, but you have to have 2013 to do this. I don't think it works in 2012. So if you have Visual Studio 2013 in your test project, I've got a reference to the assemblies that have the interfaces. I right-click, add fakes assembly. One thing you'll notice is that we'll see a fakes folder here, and there'll be an assembly created with basically the same functionality or the implementation of what we had before, or the implementation of the interfaces. So I'll do the same thing for the online stores, which has the interface iOrder store. Okay. And after it does that, it goes and creates references to those Microsoft Fakes assemblies. You can see that here and here. So it's all wired up for me. So if I go back to my test, okay, so now it sees that I've got the stub of the iOrder store available, and you can see that the concrete implementations are put in a fakes folder alongside the interfaces. For example, if you see the online store.stores.fakes, sorry, you can see the interfaces right there, and alongside that is the fakes namespace with the stub inside there. So that's where you'd find it. Okay. And we also have a stub for iLogger. In this case, we don't need the logger to do anything special, so I'm just creating an instance of stub iLogger. In the case where I have the stub of the iOrder store, I'm actually providing a little bit of behavior. I need to kind of override the store order, sorry, in this case the save order method. And what the stubs does is it provides you a property where you can pass it a delegate for every method that the interface has defined. So in this case, the interface defines a save order method, returning void, and it has a save method that you have to pass an order to it, so therefore it has a save order property. So in this case, I set into the save order property a delegate that you have to pass an order. In this case, all I'm doing in that delegate is I'm persisting the order into a local variable. And then finally, I'm calling process order, and then I'm validating that the order that I created originally is the same as the one I captured. So if I build it, I go to my test. I'm pretty sure I ran it before, but let me run it again. And we have green. All right, so we validated that the order service works, providing some mocks to perform the logging and the saving. All right. Anything else for that? No. Okay, so again, talking about testability, unit testing versus integration testing, that's a big topic. What I just did right now is I tested the unit of functionality of the process order method, and that's really only possible if you have your dependencies factored out. You don't want to be testing your dependencies, you just want to test the code that you really want to test. For integration testing or performance testing, you really want to test the whole ball of wax. You want to talk about integration testing a little bit?
Yeah, I think that there are definitely the other aspects to testing than just unit testing. So we'd want to do things like performance testing and scalability testing, and if your application has requirements for localization, then do localization testing. And you may want to also have a test suite for your integration tests. Like for example, if your application has a UI, there is this framework called Coded UI. There are other open source options too, like Watin and things like that for web. You may want to write integration tests, using those kind of frameworks too, to quickly be able to validate your application to make sure it works the way your customer expects it to do. Those kind of, acceptance tests are definitely very good to supplement a good unit test suite.
So yeah, definitely not in replacing each other. It's important to have both. Right. For me, the unit tests are really a way to capture the functionality such that I can run it really quickly. So if I were to refactor my code base, I would know really quickly if I really screwed something up. Right. Hopefully, if it's really bad, it'll be caught in other integration or acceptance tests. But it's nice to have a suite of tests where I can run really quickly. The integration test may take longer. Acceptance tests may require some manual testing, so those definitely take longer. All right. So let's talk a little bit about test doubles, fakes, and stubs. So test doubles to me is really the ability to replace the dependencies you have with something you can control. For example, if you wanted to test the database full exception, you don't want to actually fill up your database. You'd rather just have a controlled stub that throws that exception on demand. So that's really what test doubles is to me. Microsoft Fakes is the out-of-the-box mocking framework that is provided in Visual Studio 2013. And it provides stubs and shims. So I give you an example of how stubs works. Basically, you provided the interfaces, you tell it to create your fakes assembly, and it creates the stubs for you based upon those interfaces. Shims is different. Let's say there's code that you don't really control, that doesn't have an interface. For example, if you're calling statics, or you're getting an instance of something and you didn't control the instantiation. In that case, for example, datetime now. The now static method is not something you can control, and if you wanted to mock out, or let's say your test or your code does something different for different hours, let's say on even hours does something, on odd hours does something different, it's hard to really test that, because if you run your test on even numbers hours, you're going to get a different behavior than odd number hours. So if you use the Microsoft shims, that allows you to control that functionality. You can actually say that, hey, this is now an odd number hour, and the datetime now will return an odd number hour. So that's the difference. Now, I would be careful when to use shims. Shims is very, very powerful, but I would only use it on code that you don't own. So code that you can't refactor yourself to make more testable. For everything else, I would use stubs. For code that you own, and that you can refactor to make more testable, I would use stubs for that. All right. Any other comments on that?
No, I think we're good.
All right. So we have Some resources here. The Developer's Guide to Dependency Injection using Unity is a book that P&P released a little while ago. A lot of these samples come out of that book and a lot of other detailed information.
Yeah, so there are a bunch of topics like auto registration and interception and things which we did not show demos for, mainly because of lack of time. We wanted to, we didn't want the session to spill over. So, but you can actually look at the code samples which are accompanying the guide. They have samples which cover those scenarios too. So,
Right, and there's our email addresses. Let's go to some questions. Which DI container is mostly used at Microsoft? You know, I'm not sure which one is used across Microsoft.
I would say Microsoft. I have seen different teams actually use different DI containers. I think some of it has to do with what different teams are familiar with.
And the platform.
And the platform. So there are teams which are more familiar with AutoFac and they use AutoFac. There are teams which use Unity. There are teams which use MEF. So I don't have a clear answer to that.
I think for a lot of people writing applications on .NET Framework, I've seen a lot of MEF being used. Yeah. Okay, so
I think there was a question we missed in the beginning. So somebody asked, we don't see that in the screen here. So somebody asked what is the best practice for doing integration testing. So I would say there is no clear best practice, but it's good to have tests using which drive the UI, like tests which use frameworks like already UI or Watin, which do the end-to-end kind of testing. But UI testing alone doesn't help, especially in projects where the UIs keep changing, because UI is the thing that usually keeps changing the most. So it's good to have tests which test things one layer below the UI too, the integration tests, which probably make use of Visual Studio test framework or any other test framework you prefer, and which are more like the integration tests. So yeah, I mean that's pretty much the best answer I can give. Yeah.
Great.
Yeah.
So Giancarlo, I think is his name. I have a legacy monolithic application. What's the best first steps I can take towards improving testability? Well, that's a great question, Giancarlo. Thanks for asking it. I think the answer to that question is really about your new code. For example, if you want to write, if you want to fix a bug in your application, the way I would do it is I would write unit tests, or I would refactor the code that you need to touch to fix that bug. It's really too much to ask to take this monolithic application and make it DI friendly, to make it unit testable. One thing you can do is you can use shims to mock out some of the behavior that you don't control. If your code gets past things that you get from statics, let's say, because that's the only way to get it, well, then you can use shims for that. But everything else, if you can refactor the code in your narrow scope, I would do that. But I doubt if anybody has time to refactor the entire monolithic application. I would just refactor the pieces that you touch when you fix your bug, or any new features you add to your system.
Yeah. Okay. So the next question is, what's the difference between DI and MEF? I think there is no difference between, I would say dependency injection is a pattern, MEF is a DI IOC container which allows you to use dependency injection. MEF is a little different from, at least from .NET Framework 4 and below. It was a little different from other DI containers in the sense that it was something you would use for if your application had a plugin kind of architecture. It required you to decorate your types which you wanted to perform a dependency injection on using attributes. You had to decorate it with them, and it would scan all the assemblies and look for those kind of attributes and do the type registration for you. But I mean, the steps are the same in the sense that you do type registration and you resolve types from the container. So I would say that MEF is also a DI container.
Right. Yeah. Some people consider MEF not a DI container, but I think for the general happy path stories of what the DI containers are expected to do, MEF accomplishes that.
Yes. And if you, I think in .NET Framework 4.5, MEF went beyond having to specify those attributes on the types, and because if you had third-party libraries, there was no way to do DI with them. So they've made some improvements where you can do the Unity kind of type registration, where you can register types and things. So they've made a lot of improvements in 4.5. Yeah.
Okay. That was from Hishan. You have another question from Sia. Is Microsoft Fakes available on Visual Studio 2013 Professional? You know, I'm not really sure. We have Ultimate here. Of course, we are lucky enough to work for Microsoft and have available the Ultimate. I'm not sure if it's available on Professional. I would expect it would be available on Professional. May not be available on free versions.
Yeah, I think we'll try to post an answer to that question after the session is done, you know, in the
in
channel
Jabber?
line. Yeah,
In
channel line
Jabber,
or
yeah.
Jabber. So
Yeah.
we'll try to find out and let you know. So, yeah.
Okay. All right. Any other questions for us? We'll be available off after the session on Jabber to just chat and answer any other questions you may have. All right.
All right. Thank you very much.
Thank you very much.